Hi folks, so as we continue the rest of this week with multiplying polynomials, we're going to be sticking with multiplying binomials for the rest of the week. But I wanted to show you a couple special cases that come up that sometimes give people trouble. So if you have something like this, 2x plus 3 raised to the second power, all right, what this means is that you have to take 2x plus 3, and when something's raised to the second power, it means you need to multiply it by itself, right? So you need to multiply out that polynomial times itself. So in order to do this, we need to use, like we talked about yesterday, the distributive property. So you're going to take the 2x right here, and you're going to multiply it by 2x, and you're going to multiply it by 3. Right? So 2x times 2x is 4x squared, and 2x times 3 is 6x. But now again, we're not done, because we have to take this 3 right here, and we have to distribute it to the 2x, and we have to distribute it to the 3. So 3 times 2x is 6x, and 3 times 3 is 9. Right? So we end up with a final answer now. After we combine like terms, we combine the middle terms, 4x squared plus 12x plus 9 as our final answer. So that's actually the expanded polynomial answer for 2x plus 3 raised to the second power. One of the biggest mistakes people make sometimes is they just square the 2x and square the 3, and they forget all about the fact that there's going to be a middle term from multiplying it out. So make sure when you see that, when you see a problem like that, where it's a binomial raised to the second power, you multiply it by itself and do out the entire multiplication. Okay? Let's do one more like that, just to make sure. You'll see some of those on the practice work the next couple days. Right? So even if I just had x plus 8 squared. All right? Again, sometimes people think I just square the x and I square the 8, and that's going to be my final answer, but that's not true. This means x plus 8 times itself. So again, if we use the distributive property, we take this x, we distribute it to the x, and we distribute it to the 8. X times x is x to the second. X times 8 is 8x. Right? And then I do the same thing over here. I take the 8, and I distribute it to the x, and I distribute it to the 8. So 8 times x is 8x, and 8 times 8 is 64. Okay? So my final answer after I combine everything, I combine the middle terms, as we've been seeing you can usually do, x squared plus 16x plus 64 would be my final answer right there. Okay? So again, just pay attention to the fact that when you have a binomial like this multiplied by itself, that's what it means to multiply by itself. But when you multiply by itself, you have to distribute out as you normally would anytime you're multiplying two binomials. Okay? One last one I want to show you is, and this really isn't anything too special, but sometimes you might be multiplying a couple binomials out, and they might be the exact same binomial with the exception of the different sign in between. Okay? And you don't need to really remember anything special for this. You can just follow the distributive property as we've been talking about it. But you'll find something interesting that happens in the final answer. So when you do 3x and you multiply it by 3x and you multiply it by minus 2, right? So 3x times 3x is 9x squared. And then 3x times minus 2 is minus 6x. And now you take the 2 and you distribute that. So 2 times 3x, that's positive 6x. And 2 times minus 2 is minus 4. And what you'll notice in this situation is that what happens to that middle term? Negative 6x plus 6x adds up to 0. Right? So there isn't going to be a middle term. This adds up to 0x. So our answer will end up being 9x squared minus 4. So you can do that one out normally with the distributive property, and it's just going to happen that that middle is going to cancel out. And we'll talk more about that later on in this unit. That's actually what we end up calling a difference of squares. But I don't want you to get hung up on that terminology too much right now. You can just do it out as a normal problem, but don't be surprised if you see the middle cancel out like that when the original polynomials look like that. Okay, so the rest of the week we're going to just keep working on multiplying with binomials. If you have questions, make sure you contact me. Have a good day.